Hello and welcome to closure problems 127 and 128. When 127, it asks for the converse of each statement and then determine if the converse is true. This one says if two lines are parallel, then corresponding pairs of angles are congruent. So the converse would be we keep the if and the then in the same spot, but we take this part and pairs of corresponding angles are congruent, all this part here, this second part, and these guys get switched. So the converse should say, if pairs of corresponding angles are congruent, then two lines are parallel. And that is true, because we know that if the correspondings are equal, that means that these are parallel. If the sum of measure A and measure B is 110, then measure of angle C has to be 70. The converse is, if angle C is 70 degrees, then the sum of A and B is 110. And that's also true. If alternate interiors formed by two lines cut by a transversal are not congruent, the two lines are not parallel. The converse is, if the two lines are not parallel, then alternate interior angles formed by two lines cut by a transversal are not congruent. And that is true. If Johann throws coins in the fountain, then he loses his money. Change it around. If he loses his money, then he must have thrown his coins into the fountain. That converse is not necessarily false. There's lots of ways he could lose money. It doesn't have to be because he put it in the fountain. Maybe he has a hole in his pocket or something else. So the converse here is false. In problem 128, it says to find the measure of the angle in an equilateral triangle and justify your conclusions. So if all three sides are equal, we know the biggest sides are always across from the biggest angles. We also know in an isosceles triangle, the base angles are always going to be equal. But in this one, if all the sides are equal, then the angles opposite them are equal. So this angle has to be the same as this angle and the same as that angle because the sides across from them are all equal. So if they all add up to be 180 and there's three of them, if we divide, that leaves 60, 60, and 60. In the second one, we have an isosceles triangle. What are the measures of each of the angles in an isosceles right triangle? Well, we know if these sides are equal, then these angles are equal. And together they have to add up to be 90. So if we just divide by 2, that leaves 45 and 45. What if you only know one angle? What if angle A is 34? Well, we know in an isosceles triangle, the opposite sides are equal to the opposite angles, so those angles have to be the same. So we know that if we call these x, we know 2x plus 34 has to be equal to 180 altogether. So 2x equals, if I subtract, that is 146. And dividing by 2 leaves me 73. So each of these are 73. Those are the closure problems.